So in this last section, we'll cover a process of separating the components of a mixture known as distillation. So depending on the type of mixture, we can employ different processes. For a heterogeneous mixture, let's say you have a mixture of a precipitate and a solution, like we've seen in one of our experiments, we would use filtration to separate the components. But what if you have a homogeneous mixture? So let's say you have, I don't know, solution of copper 2 sulfate or a solution of lead 2 nitrate or potassium iodide. How could you separate the components of that mixture? Well, we use a process known as distillation. So again, some vocabulary here for you. Volatile refers to a substance that can evaporate or that does evaporate and thus has a vapor pressure. So we'll talk about techniques for separating homogeneous mixtures where the solute is non-volatile versus when the solute is volatile. So let's start with simple distillation. We have two types. We have simple and fractional distillation. Simple distillation, as the name implies, is a little more simple than fractional distillation. So we use this process when the solution consists of a non-volatile solute and a volatile solvent. So remember, non-volatile means does not evaporate. And so we'll see how we're able to do this in just a second. So right now, actually. So here's what we do. Let me give you an example, and then we'll walk you through. So you can fill out number 3. An example would be salt water. So let's say you have a solution of salt water. So remember, the salt is dissolved in the water. We can't see the salt in there at all anymore. Certainly cannot separate the salt from the water by filtering. Both components will just go right through the filter paper. So here's what we do. You take the solution and you boil it. Now, when you boil a solution that contains a non-volatile solute, the only substance that boils is the solvent, in this case, the water. So we talked about this with the boiling point of a solution lab. So only the solvent boils. And so the vapor that results from the boiling of that solvent consists only of that one component. So what you do is then you take the vapor, so that's just the gas produced from the liquid that evaporates or boils. You collect that vapor and then you cool it so it will recondense. So condense means to change into a liquid. So you take the gas, collect it, cool it down so that it will turn back into a liquid. This product is then pure because the solute component will remain in the original solution. So just boil that solution completely, collect that vapor will be pure solvent, and then the solute will be left behind in your container. So if you took like a pot of salt water, put on the stove, and completely boiled away the water, you'd be left with a white residue inside the pot. That white residue would be the sodium chloride. The process is quite a bit more complicated if the solute is volatile. So let's fill out an example. So underneath number 2, so just write number 3. Example would be a mixture of water and ethanol. So ethanol, like water, is a liquid. They dissolve in one another. They are miscible. It's another vocabulary term. However, this time, as opposed to the previous example, both components are volatile. So here's what we do. Again, it starts off the same. So you're going to take the solution and you're going to boil it. However, that vapor that you end up with will consist of both solute and solvent components because both are volatile. However, you're going to have more of the more volatile components. The vapor is richer or more concentrated in the more volatile components. So the more volatile substance is the one that's going to evaporate more readily, more easily, and so your vapor is going to consist more of that substance. So once again, you take that vapor, collect it, cool it, and condense it. So it's kind of out of order here. You got to collect the vapor first, cool that vapor, and condense it back into a liquid. So now again, you still have a mixture. You have both solute and solvent in that recondensed liquid. So you boil it again, And the vapor this time consists of even more of the more volatile component than the first time. Take the vapor, collect it, cool it, condense it, and repeat this process until you have completely purified the more volatile component. So a little bit more complicated. It's a process where you just have to repeat the steps. Keep doing this until your vapor is eventually all of the more volatile component. Take a look at the bottom of page 525, figure 21.2. This shows we have a mixture of toluene and benzene, both which are volatile liquids. And the x-axis, we got a mole fraction of benzene. So all the way to the left, we have pure toluene, so no benzene, so it's 0. And then all the way to the right is pure benzene, no toluene, so mole fraction for the benzene would be 1. And then on the y-axis, we have temperature. So it shows the difference between the composition of the liquid and the composition of the vapor. And so again, you will collect when you heat up the solution. Your vapor will consist of more of the more volatile substance, and so continue the process until you have collected that substance. Page 526, 21.3 shows what's called a fractioning column. And so instead of having to collect every time the more volatile component, you can run it through what's called a fractioning column, which will isolate one of the components of that mixture, and then again allow you to separate the components of that mixture. So just keep in mind that we have a different process for different types of mixtures. Heterogeneous mixture we can separate using filtration. Homogeneous mixture we can use distillation. Another process we did not talk about is called chromatography. That one you may learn about in AP or IB chemistry. Won't talk about that here. And then with distillation, depending on what type of solute you have, you may have to just heat up that solution once and collect the vapor, or you may have to heat it up, collect the vapor, heat it up, collect the vapor, depending on the solute. All right, that concludes this lesson. That concludes this unit. Thank you for watching.